Okay, guys, here is 13 part 2. Part 1, we're going to do the summation notes and stuff like that tomorrow, but I wanted to introduce you to our arithmetic sequences. When a sequence is arithmetic, right, that is the same thing as a linear function. So linear function, all right, we're going to equate this to a linear function. I'm upstairs in the lounge and Miss Arango is playing music, so if you hear that in the background. We think about our linear function, makes a line when it's graphed. It's y equals mx plus b, where b is your y-intercept and m is your slope. So in an arithmetic sequence, we're going to find those two things. We're going to find the intercept and the slope. We're just going to call them different things. So with an arithmetic sequence, you are going to add or subtract the same number every time to get to the next. Right? This is going to be adding or subtracting to get from one number to the next. Here is the formula to find the rule for an arithmetic sequence. A sub n means whatever number you're looking for, the 9th term, the 12th term, it's the nth term. You need the first term of the sequence. So this is the first term. Whatever the sequence is, you'll see, first term. Is the term you're looking for. It's the term number you're looking for. And then D is your common difference. It's what's being added or subtracted every time. So again, we're going to talk about two different kinds of sequences, arithmetic and geometric. So an arithmetic is, like I said, it's a linear function, and you're going to add or subtract the same number to get from one to the next. So if you have a question like this, here's your sequence. How did I get from one term to the next? Okay, from 13 to 7. I subtracted 6. From 7 to 1, I subtracted 6. From 1 to negative 5, I subtracted 6. So we have established that to get from one term to the next, you're subtracting 6 each time. That's your common difference. It's what do they have in common to get from one number to the next. So we identified here the common difference. So if I'm going to use the rule that they gave us to find the nth term, a sub n equals, it's the first term plus n minus 1 times your common difference. So I look and I say, okay, well, the first term of this sequence, my first term right here is 13, right? So I'm going to plug in 13 here, plus n minus 1 is going to stay our variable because that's what we're trying to find, the rule for this. And what was our common difference? It was minus 6. So I'm going to put right here, I'm going to multiply this times negative 6. So first thing I'm going to do is distribute. So I have 13 plus a negative 6n, and then a negative 6 times a negative 1 is going to be plus 6. And in this case, we can combine like terms here. So I have a sub n equals negative 6n plus 19. So right here, we just wrote the rule for this arithmetic sequence. So if I was going to say, okay, well, what's the fourth term? So this is the second, the third, and the fourth. So the fourth term of this sequence we see is negative 5. So let's just check our rule and see. If I say negative 6 times, I'm looking for the fourth term. That's what I put in for n, plus 19. Well, negative 6 times 4 is negative 24 plus 19. Negative 24 plus 19 equals negative 5. What is the fourth term of this sequence? Negative 5. So that's the rule that we wrote. Now, the reason I tell you guys that arithmetic is the same as linear, because I want you to see the, I want you to see the correlation. If you were to tell me that to get from one point to the next every time, you're going down 6, right? So that's our common difference is down 6. We can also name that as our slope. So if I was going to follow y equals mx plus b, instead of y, I would put a sub n, and my slope here would be negative 6. Instead of an x, I'm going to put my n value. Then I need the y-intercept. Well, in a case like this, guys, if this is your x and this is your y, this would be your quote-unquote 0 term. So to get from 1 to 2 to 3, we subtracted 6. To go backwards, to get the term before it, you would have to add 6. What is 13 plus 6? Positive 19. Which, guys, if you notice, is the exact same thing we got here. So you can always use this a sub 1 plus n minus 1 every time, but you can also use the y-intercept or the 0 term and the slope that you find to find the rule. Either way, it doesn't matter to me. Now, if you're asked to find the 300th term, well, what you're asked to do is take the rule that you wrote, a sub n equals negative 6n plus 19, and we're going to find the 300th. So I'm going to plug in 300 for the letter n. So I have negative 6 times 300 plus 19. This is very helpful, guys, so you don't have to start from the first term and then just keep subtracting 6 each time, 300 times to get to the 19th, or to get to the 300th term. So when I plug this in, I get negative 1800 plus 19, and I found that the 300th term of this sequence is negative 1781. So in this process, we did 3 different things. We found our common difference, which is the same as our slope since we're arithmetic. We wrote the rule that would help us find any term of the sequence, and then we found a specific term of the 300th term. All right, here's another type question that you guys might see, and we're only going to do this first part today, and then we're going to do the second part on Thursday. But when you're given certain terms, and you're asked to find the 1,000, so that means we have to find the rule. So we have to find a sub n equals a sub 1 plus n minus 1 times your common difference. And then they want us to find the 1,000th term. So let's look and see what we have. We have that the 11th term is 52. And we have that the 19th term, so 11, 12, 13, 14, 15, 16, 17, 18, 19th term is 92. Now there's a variety of ways you could do this. You could count, you could try and figure it out, but since we know that an arithmetic is also a linear function, when you're finding the common difference, you're really finding the slope. So if this is my x value and this is my y value, I could write this as an ordered pair. I could say, well, 11, 52, and then I could say 19, 92. And now we just find the slope. So 92 minus 52 over 19 minus 11. 92 minus 52 is 40. Divided by 19 minus 11 is 8. So what is your common difference each time? It's positive 5. How are you getting from one term to the next? You are adding 5. So again, there's different ways that you could do this. I'm going to show you 2 different ways that I think are perfect. But use what they have given you to figure out what the first term is. Because now, in order to write the rule, we have to know the first term or the 0 term, depending on how you want to look at it. But in order to write the rule to find the 1,000th, we got to figure out what the actual rule is itself. So I'm going to take the 11th term, because they told me what the 11th term was. So I'm going to plug that information in, and I'm going to find out what the first term is. Watch this. So they told me here that the 11th term was 52. So a sub 11 is 52. Trying to find the first term. And again, we're using the 11th term, so I'm going to plug in n is 11 minus 1 times your common difference was 5. All right, n is the number term that you're talking about, so we're talking about the 11th. So I have 52 equals a sub 11 plus 11 minus 1 is 10, and 10 times 5 is 50. I'm going to solve that. Oops, I'm sorry, I'm trying to find the first term, not the 11th. Should go 1. So I'm going to minus 50 from both sides, and I found that the first term was 2. So a sub 1 equals 2. My common difference is 5. We can now write the rule. A sub n equals first term plus n minus 1 times the common difference. Your first term is 2 plus n minus 1 for whatever number we're looking for times the common difference, which is 5. So we're going to distribute. We have 2 plus 5n minus 5. I can combine like terms here. And my rule for this sequence is a sub n equals 5n minus 3. Now, some of you are saying, well, what about if I wanted to use the other piece of information they gave me? I wanted to use that they gave me the 19th term. Okay, well, watch how that works. I could say, same thing. A sub 19 equals a sub 1 plus n minus 1 times the common difference. Well, the 19th term here was 92. So I'm going to say 92 equals, I'm still trying to find the first term, plus, and we're talking about the 19th term, so 19 minus 1 times your common difference, which is 5. 92 equals a sub 1 plus, this is 18 times 5 gives me 90, I'm going to subtract 90 from both sides. And again, guys, what do I get? I get that the first term is 2. So if you notice, with both pieces of information they gave me, I could figure out I got the same thing. So the rule that we just wrote for this sequence is here. So now, if I'm asked to find the 1000th term, I say, okay, well, a sub 1000 equals 5 times, I'm trying to find the 1000th term, minus 3. So I have 5,000 minus 3. And I find out that the 1000th term of this sequence is 4,997. Tomorrow we will finish these notes. I'll do this with you. I'll recap this a little bit. But tomorrow we're going to talk about partial sums of an arithmetic. So kind of what we did yesterday, but I have a specific formula that you can use to find your answer.